जय हिंद स्टूडेंट्स, आप लोग कैसे हैं? I hope you all are staying fit and you are also studying well, right? Don't lag behind the syllabus and do study on a consistent basis. So let's start today's session. Today we are going to discuss the last topic of the first unit, that is motion, and the last topic is uniform circular motion. As the term suggests, circular motion means a body moving along a circular path. An athlete cycling or a motorcyclist moving along a circular track, or a satellite moving around Earth in a particular circular orbit. So all these examples are of circular motion, right? So before we start with circular motion, let me brief you about the concepts which we have earlier discussed. Like acceleration, students. You all are aware of acceleration. Whenever the velocity of a body changes, then the body is said to possess acceleration. Mathematically, acceleration is given by the time rate change in the velocity of the body. That is, acceleration is change in velocity divided by time, right? This is the formula for the acceleration. Change in velocity divided by time. So first and foremost, we'll try to understand what are the various options for a body to possess acceleration. What needs to be done for a body to have accelerated motion? So what needs to be done? Its velocity needs to get changed. Now look, velocity is a vector quantity. We all are aware of it. And vector quantity means it has got both magnitude as well as direction. It has got both magnitude as well as direction. So students, in order to change the velocity of a body, there are three options. First, you can change the magnitude of the speed of the moving body. Second option is you can change the direction of motion of the body. And third option is you can change both magnitude as well as direction. So out of these three options, if one option is applied, then the body will be in accelerated motion. So I repeat, in order a body to have accelerated motion, its velocity needs to get changed continuously, right? And in order to change its velocity, what we can do is to change the magnitude of the speed of the moving body. Second is we can change the direction of motion of the body. Third is we can change both the magnitude of the velocity as well as its direction of motion, right? So keep this in mind. Whenever either of these three conditions are satisfied, then the body is said to be in accelerated motion. And if it happens that the change in velocity is constant, the velocity of the body changes at a constant rate, then it must be the case of uniformly accelerated motion. And in case the velocity of the body changes but not at a constant rate, then it will be the case of non-uniformly accelerated motion. Right, students? Okay. With this basic knowledge, let's start with this particular topic of uniform circular motion. So before we deal with the actual topic of uniform circular motion, I will give some sort of illustration. Let us consider some closed path. It can be in the form of a triangular shape, or the path can be in the form of a square or rectangular or hexagon or septagon or octagonal shape, right? So let's consider these closed paths. Suppose this is a closed path which is in the shape of a triangle, right? Second is, let us consider this to be a closed path which is in the form of a square or a rectangle having four sides. Let's consider another path which is in the form of a hexagon like this. It is a closed path which is in the shape of a hexagon, means having 6 sides. Let's consider another path. So let's consider the case of a path having 8 sides, octagon. This is a closed path having 1, 2, 3, 4, 5, 6, 7, 8 sides. It is known as the octagon, right? So we can keep on increasing the sides. Look here, it has got 3 sides. Here it has got 4 sides. Here it has got 6 sides. And here it has got 8 sides. Right? So what we are considering is a body to be moving along a closed path. And that closed path may be of any shape. Triangular, square, hexagonal, octagonal, and so on, right? So let's consider the first case. Here the body starts from point A and reaches point. It starts from point 2, reaches point A, then reaches point B, then again it comes back to point 2. This is the path which it follows in the anti-clockwise direction. Let us assume it. Now, in order to complete one complete revolution, right? How many times the body needs to change its direction? So, this is the original direction of motion. This is where the body initially moves. So, in order to follow this path, at point A he has to change its direction. Then he is moving along this direction. In order to move along BO, he needs to change its direction at point B. Now he will move along this direction. Again, in order to have its original direction of motion, he has to finally change his direction at point O. That is, in order to complete one complete loop, one complete round, in this case, the person or the body will have to change his direction of motion thrice, that is 3 times. Right, students? Let's consider this case. Suppose the body starts from here, he reaches point A, then he reaches point B, then he reaches point C, and again finally comes to point O. This is his original direction of motion. Now, in order to complete one round, how many times in this case the body needs to change its direction? Let's see. So, this is his original direction of motion. In order to follow path AB, here he needs to change its direction of motion. Then again, on reaching B, if he intends to move along BC, then at point B, he needs to change its direction of motion. Then again at point C, he needs to change its direction so as to move along path CO. So this is the 3rd time. So now he is moving along CO. Finally, if he intends to move along its original direction of motion, then he finally needs to change his direction of motion at point 2 so as to be able to move along the original direction of motion. So students, here the closed loop, it has got 4 sides, and in order to complete one round, he has to change its direction 4 times. Right? Do observe the logic. Here the closed path has got 3 sides. So the person or the body moving along this closed path having 3 sides will have to change its direction 3 times. If a body is moving along a closed path which is in the form of a square or rectangle having 4 sides, then he has to change its direction of motion 4 times. Number of sides, which will be equal to the number of times the body needs to change his direction so as to complete the loop. Right, students? Let's consider this case. Right? Suppose the body is starting from point A, so he goes to point A, then point B, then point C, then point D, then point E, and finally to point O. Now, in order to complete one round, how many times he needs to change his direction of motion? 1, 2, 3, 4, 5, 6 times. Then only he will be again able to go along its original direction of motion. So students, here again, closed loop has got 6 sides. So the body, in order to complete the loop, has to change its direction 6 times. Similarly over here, generalize the concept. Over here, the closed loop has got 8 sides. It's a case of an octagon, right? So, in order to complete the loop over here, the person needs to change his direction 8 times, right? So, student, imagine that the sides of the closed loop is increased gradually. Here it has got 8 sides, then 10, then 12, then 16, then 24, 48, and so on. Suppose the number of sides of the closed figure keeps on increasing gradually. So the number of times the person or the body has to change its direction will also change accordingly. It will also increase accordingly. So how do you consider a circle? Circle, students, mathematically may be defined as a polygon having infinite sides. Now if you keep on increasing this side, like this, if you keep on increasing this side, it will become curved. So actually it will become a circular path. So how do you define a circle, students? A circle is a polygon. Poly means many. It is a geometrical figure having many sides, many angles. So circle is a polygon having how many sides? Infinite sides. So the circle may be defined as a polygon of infinite sides. So let's extend the logic to a body moving along a circular path. Since the circle can be imagined to be having infinite sides, so a body moving along a circular path must be changing its direction of motion infinite times. Am I clear, students? Again I repeat, whenever a body tends to move along a circular path, then its direction of motion changes continuously, that is infinite times. Right, students? So, a body moving along a circular path, its direction of motion changes continuously. Now direction changes. Therefore, velocity of the body is changing. And whenever there is a case of change in the velocity of the body, it must be the case of an accelerated motion. So that is the reason why, students, a body moving along a circular path is an example of an accelerated motion. Clear, students? Again I repeat, it's a very, very useful and important concept. In order to follow a closed path having 3 sides, a person, in order to complete the loop, has to change its direction 3 times. If the side number of sides is 4, he has to change his direction 4 times. If the number of sides is 8, he has to change his direction 8 times. In the case of a circle, it is a polygon of infinite sides. Therefore, a body moving along a circular path has to change its direction infinite times. Or in other words, it suggests that whenever a body moves along a circular path, its direction of motion changes continuously. Continuously its direction of motion changes. So when the direction of motion of the body changes, it means that the velocity of the body under consideration must be changing. And students, whenever the velocity of the body changes, it means that it must be the case of accelerated motion. Therefore, a body moving along a circular path is an example of an accelerated motion. Fine. And what are the examples? Just as I have told you, an athlete running along a circular track, right, running around, or an artificial satellite revolving around the earth in a circular fixed orbit. All these are examples of circular motion which are accelerated motion. So point to be noted is that even if the magnitude of the velocity of the body do not change, yet when a body moves along a circular path, its direction of motion keeps changing continuously. And due to change in the direction, the velocity of the body changes, and accordingly, uniform circular motion is said to be an accelerated motion. Right? Okay. Now suppose this is the center of the circular path and this is of radius r. At this point, students, suppose the body is moving in the anti-clockwise direction. At this point, if someone asks you, the body moving along a circular path, what will be its direction of motion at point A? It will be given by drawing a tangent at this particular point. Tangent means it should be perpendicular to the radius. That is known as tangent, right? So this is the tangent. It should be, this is the radius and this is the tangent. So this is the direction of motion of the body at point A. What about the direction of motion of the body at point B? Again, you need to draw a tangent over here. You need to draw a tangent over here. This will be the radius, so it will be perpendicular to this. Understood? So over here, or over here. The direction of motion of the body would be given again by drawing a tangent. Tangent means perpendicular to the radius. When a body moves along a circular path, the direction of motion of the body at any instant is given by drawing a tangent at that particular point. Since the body is assumed to be moving in the anti-clockwise direction, so you need to draw the tangent in that particular direction. So, this is the concept. At any instant, a body moving along a curved path, the direction of motion is given by drawing a tangent at that particular point. Right? If the body is at this point, then the body is moving along this direction. So its direction of motion at this point will be given by drawing a tangent at this particular point. So this will be the direction of motion of the body. Clear, students? I can give you an illustration, a simple illustration. Suppose, consider a string and hold its one end with your hand and tie the other end with a stone or a ball and then whirl it so that it follows a horizontal circular loop. Right? Suppose it follows a horizontal circular loop like this. This is center and this is stone tied. And just whirl it in a horizontal circular motion. What happens is, if by chance at this instant the string breaks, then the stone will fly tangentially. Right? It will fly tangentially. If the string breaks over here at this juncture, at this point, then it will fly along this direction. If the string breaks at this point, then the body will fly along this direction. So that's because the direction of motion of a body which is moving along a curved or a circular path at an instant is given by drawing a tangent at that particular point. Clear, students? So that's the concept involved. Now let's try to find an expression for the velocity of the body moving along a circular path. Let us consider a body to be moving along a circular path of radius r. Suppose this is center and it is following a circular path of radius r, maybe in the anti-clockwise direction. This is the anti-clockwise direction, right? And you are aware, suppose the body starts from point A. The total time taken by the body to complete one revolution, that is known as its time period. That is known as its time period. Time taken by the body to complete one revolution. So, the body is starting initially, that is t equals 0, and in order to complete one complete rotation, suppose it takes time t. So, capital time t is known as the time period. It is known as the time period. Right? And suppose the body is following the circular path with speed v. With speed v. This is the radius and tangent. It is always right angle to the radius. So, while moving along the circular path, let us assume the speed of the body. Speed means the magnitude of velocity of the body to remain constant. Listen to me very carefully, students, right? You need to judiciously use the term speed and velocity. Speed is a scalar quantity. When I talk about speed, it means that I am talking about the magnitude of velocity, which is speed, right? So here what I assume is a body moving along a circular path with constant speed. Speed is constant, means the magnitude of velocity remains constant at every instant of time. But direction of motion is changing. Therefore, although speed is constant, but velocity is changing. So here, speed is constant, but velocity is changing. Why velocity is changing? That is due to the change in, continuous change in direction of motion of the body. Right? So, in this case, the velocity, average velocity of this body moving along the circular path would be given by total distance covered divided by total time taken, isn't it? So what is the total distance covered during one complete rotation? It will be equal to the circumference of the circular path. And the circumference of a circle of radius r is 2 pi r. So what will be the distance during one complete rotation? It is 2 pi r. So And what is the time taken by the body to complete one rotation? It is capital letter T, which is the time period. So I've used this formula. Average speed is equal to distance, total distance, divided by total time. So during one complete rotation, it covers a total distance of 2 pi r. So make use of this particular formula, right? While solving questions related to circular motion. Average velocity is equal to 2 pi r divided by capital T. Capital T is the time period, which is the time taken by the body to complete one rotation. Right? Okay. Here I must state that in this case, acceleration is also vector quantity, you all are aware. In this case, when a body moves along a circular path, right, with constant speed, then the body possesses only one type of acceleration, which is known as centripetal acceleration. And that acceleration always points along the radius towards the center. This is the direction of acceleration basically. This is known as centripetal acceleration. So student, what type of acceleration does the body possess while moving along a circular path with constant speed? It is the centripetal acceleration. AC, it stands for centripetal acceleration. Right? What is its direction? It is always directed along the radius towards the center of the circular path. Right? What is the purpose of this acceleration? It makes the body to move along a circular path. It do not change the magnitude of velocity of the body. It do not change the speed of the body. It only changes the direction of motion of the body continuously. Right? And another acceleration is the tangential acceleration. Tangential means it must act tangentially. If a body also possesses tangential acceleration, then the magnitude of speed must also change. That is, in this case, the body must follow a circular path with varying speed. Here suppose the speed is given by v1. At this instant suppose the speed is v2. Look at the change in the length of the arrow. I am gradually increasing the length of the arrow, right? It is v4. So what happens is, in this case, the body is moving along a circular path, but with varying speed. Its speed is increasing. v1, here v4 is greater than v3, v3 is greater than v2, v2 is greater than v1. So in this case, tangential acceleration also exists. What does this tangential acceleration does? Tangential acceleration changes the speed of the body. What does the centripetal acceleration does? It makes the body to change its direction continuously and makes the body to move along a circular path. So students, please keep this in mind. If a body is moving along a circular path with constant speed, then this acceleration is not present, only centripetal acceleration is present. Right students? And it always acts along the radius towards the center of the circular path. So it is the case of uniform circular motion. Right? Which is obviously an example of an accelerated motion. In this case, if the body follows a circular path with varying speed, varying speed means, and following a circular path means, its magnitude of velocity also changes and direction of motion also changes. In that case, it will possess both centripetal acceleration as well as tangential acceleration. Tangential acceleration, the direction of tangential acceleration is along this direction. This will be the tangential acceleration. That is, it will act tangentially. This will be the direction of the tangential acceleration. It will act tangentially, perpendicular to the radius. So, what is the role of tangential acceleration? It changes the magnitude of the velocity of the body. It do not change the direction of motion of the body. Right? So, if the body possesses both these two accelerations, centripetal as well as tangential, then the body, while moving along a circular path, not only changes its direction continuously, but changes its magnitude of speed as well. Clear, students? So, this was regarding uniform circular motion, and this is the case of non-uniform circular motion. Both are accelerated motion. Both are the examples of accelerated motion. But this is the case of uniform circular motion when the body is following circular path at constant speed. And this is the case of non-uniform circular motion when the body is following a circular path but with varying speed. In that case, the body possesses both centripetal as well as tangential acceleration. Right? Okay. Now, we are in a position to discuss these two numericals. Let's concentrate on these two numericals, students. The first question is quite simple, both the questions. An artificial satellite is moving in a circular orbit of radius 42,250 km. Calculate its speed if it takes 24 hours to revolve around the Earth. So what is the time period? Time period means time taken by the satellite to complete one revolution. So that is time period. So it is given to be 24 hours. And what is the radius? It's given to be 42,250 km. So average speed. It's the total distance covered during one rotation. One revolution in this case, that will be equal to 2 pi r. R is the radius. And time taken to complete one revolution is capital A. We need to make use of this particular formula. So what you get is 2 pi is 3.14. Radius is 42250 divided by time is 24. Now it's measured in kilometer and it's measured in hour. So if you solve it, it will be in kilometer per hour. So on solving, I'm very sure we'll be easily able to solve it. It will be 11055 approximately 0.41 kilometer per hour. You can easily solve it, right? So it will be 11055.41. This is the approximate value. I hope you will do the needful calculations and you can check the result. Now in case you need to express the result in terms of kilometer per second, per hour. Hour is 1 hour is 60 minutes, each minute is 60 seconds. So it will be, answer would be in kilometer per second. So it will come out to be about 3.07 kilometer per second. So just please do the needful calculations and you will get the desired result. Right? This is in kilometer per hour and this will be in kilometer per second. In order to convert hour, you need to multiply by 3600. 1 hour is 60 minutes, each minute is 60 seconds. Right, students? So it was a question based on the direct formula, V equals to 2 pi r by t. Similarly, we can consider the second question. It's an important and interesting one. Let's see. Okay, a point traversed 3/4 of the circle of radius r. Look, this is center, this is the radius. A body starts from here, right? 3/4. It can be divided into 4 equal parts. These are the 4 equal parts. First, second, third and fourth. A body starts from this point. Suppose this is point A and covers 3/4 of the circle. Total 4 parts. Out of these 4 parts, the body has covered 3 parts. So this will be it. First part is completed. This is second part and this will be the third part. So this will be the final position of body B. Right? 3/4. So body has covered this distance and finally he reaches point B. Now look, find the magnitude of average velocity. Now look, this is the key word, velocity, not speed. It is the velocity given. Now velocity is, average velocity is net displacement divided by time taken. This is the formula. So this is the initial position and this is the final position. So students, displacement, shortest possible distance between the initial and the final position, given by an arrow whose tail coincides with the initial position and an arrowhead should coincide with the final position. So this is the arrowhead. This will be the displacement. So this is R, this is R. It's a right angle triangle. So we can very much make use of Pythagoras theorem. So we'll get the hypotenuse to be root 2r. I'll convince you. It's a right angled triangle. This one is a right angled triangle. So we can make use of Pythagoras theorem. So as per Pythagoras theorem, hypotenuse square is equal to base square plus perpendicular square. So base is r and perpendicular is also r. R is the radius. So it would be equal to twice r square, or h would be equal to square root of 2r square. So that will give us root 2r. Right, students? So the displacement from point A to point B is the shortest possible path, right? And given by an arrow whose tail coincides with the initial position and arrowhead coincides with the final position. So what is the net displacement? It is root 2r. And what is the time taken by the body to cover this 3/4 part of the circle? That is capital T. R is already given in the quotient, T is already given in the quotient. So we need to express the answer in terms of the given values, right? So this is the average velocity of the body. So I hope, students, you have understood the minute details of circular motion, non-uniform circular motion, then uniform circular motion, the concept of acceleration, how a body can get accelerated either by changing its direction of motion or changing its magnitude of velocity or both. So I hope you will watch this video till the end and you will watch it again and again till you understood each and every concept, minute concepts, right? So have confidence in your abilities and don't shy away from hard work. Do practice more and more numericals. All the best, students. Good luck.